Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Technologist Sulaiman bin Ismil. Today I will present about flexible behavior of concrete beam reinforcement with carbon fiber reinforced polymer, CFRP, plate and plain bar. This is my research for using two kind of new one. The new one is carbon fiber and plain bar is a conventional one. So we go to the next slide. As a introduction for this research, as we know, the wrought iron into the widely used in concrete with as we know today, like there are many in the construction using wrought iron. Okay, they said, but if there is a problem about this wrought iron, as we can see here, still we correct with the structure are exposed to aggressive environment like water and everything. The third one is FRP can be replaced as a conventional steel to solve the problem of corrosion resistance. So we go we go to the literature review. From the past researchers from one Amiza, Ismil, and Abdull in 2017, they are studied about, they define the flexible behavior of single and hybrid fiber concrete beam using three types of fibers. There are the three types of fibers is FSF, steel fibers, polyester chrome fibers, and coil fiber. They also found that the compressive strength of can be decreased when a fiber present in concrete. And the third one, they have found that hybrid fiber reinforcement of cement composite is one of innovative that promising way to improving the mechanical performance and durability of cement-based material. So this is my methodology. This research are focused to the three type of reinforcement beam with a dimension of 100 mm times by 150 mm cross section, and the length is 2,300 mm. The reinforcement concrete beam are using a CFRP plate, plain bar, as steel bar. The steel bar is using for as a control. So I'm focused to the CFRP and plain bars research. For this research, I'm using the concrete mixture was designed to the compressive strength to the 28 days of 35 megapascal compressive strength, and the cost aggregate using the size of cost aggregate is 10 millimeters with the water cement ratio is 0.47. It's normal ratio or standard one, and the plain mixture must be passed to 180 millimeter slump test. The reinforcement using the reinforcement use of carbon using unidirectional Sika carbon gel is the company of Sika that produce this carbon gel CFRP. I'm using this type of CP for CP beam, and the beam will be tested under 4 point of loading until the failure. Okay, next go to the as you can see here at this picture, this one is SC, PB and CP. SC is steel, and PB is plain bar, and this one the carbon one. So this is my focus. And here as you can see here, this one the 4 point of loading will be here, 2 and 2 here. Okay, at the cross sectional, we can see here the location of the bar and plate. You can see here. Okay, this one is a detail of beam tested. Okay, fine. Okay, next go directly to the result of analysis. There are four kind of result I will show to you. The first one is load deflection of behavior. As we can see here, the deflection near to failure is the highest one is SC. The highest one is SC. It means that but the first ultimate load here. Okay, ultimate load here, the experimental value of ultimate loading capacity was higher for SC beam. SC beam here, you can see 39 kilonewton compared to the theoretical ultimate load value, that is 23.36. That one is for ultimate load value theoretical. Okay, you can see here I'm putting the graph like here. Okay, you can see here. Okay, from you can see the figure, this figure. The ultimate load of SC beam here is higher than CP and PB. Because beam can carry load until reinforcement yield and the concrete fail in compression zone. That's why concrete is more higher than PB and CP. On the other hand, for CP and PB cannot carry higher load because bonding of probably between reinforcement surface and concrete members already failed. That's why it's quite big load. It cannot be transferred to the reinforcement. That's why the ultimate load for these two beams are quite big low. Okay, as you can see here, also here the stiffness. Okay, the stiffness of SC beam is much better than CP beam also. CP beam and PB also. Okay, as we take the sample over here by loading at 10 kilonewton. When we go to the first line here is for steel concrete. The value of stiffness deflection is 4 point something here, but for PB is 6 point something, and here is 10 point something. So you can see the highest stiffness is for SC, the lowest one is CP, but it still can be used. Become a reinforcement concrete. Okay, the next one is concrete strain. This situation, as you can see the graph here, this situation is same for the beam because when load apply, the diagram here you can see here, it is the same diagram. Okay, as you can see here, because when load applied to the beam top surface of the beam will become the compression zone, and the bottom surface also become the tension zone. That's why the graph is like here. Alright, below this, at this picture you can see after loading test, the flexural test, as you can see, CP diagram is you can see the pattern of the you can see the failure mode here. SC mode of failure of SC is flexural and tension only. There are no bonding. You can see CP and PB, they are bonding failure here. You can see the bonding failure is horizontal one. Description. SC is reinforcement before concrete field is compression zone, but for CP concrete field in compression zone. PB also like SC. Okay. As you can see here, the number of crack here, characteristic of crack. The highest one is SC, but there are no bonding mode failure for this SC. Okay, we see to the load of the first crack here. The fastest one, the CP, 3.8 kilonewton failure. the first crack. You can see the first crack at 3.8 kilometer. Alright, so this one is average for cracking spacing. Alright, for as a conclusion, rebar steel reinforced concrete beam had higher ultimate load compared to the CP plate and plain bar. This is because lower bonding probability between reinforcement and concrete. That's why I'm asking, I've shown you at the analysis before. And the second one is steel reinforcement concrete beam showed higher stiffness value compared to the plain bar and followed by CP and plain bar and CP. Okay, you can add the picture before. All beam are failed in the fracture test, but CP can be used as an alternative reinforcement. It can be used as an alternative for steel bar. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.